All right, so here is my physics content. I'm going to zoom in so you can see. It goes from page 118 to 160. Okay, now we're going to go on to the physical science tab. Here's my title page. I thought that was really cute, the kid being interested in what his teacher was doing. And here's the vector scalar, or speed versus velocity, distance and displacement. So here's displacement versus distance. Vector, speed, here's acceleration and deceleration. And I color coded everything that's green or boxed in green is acceleration, deceleration's all the pink. Here's the four forces of nature. We'll start with the top one, gravitational force. Strong nuclear force. Weak nuclear force. And electromagnetic force. Alright, types of motion. Here's two of them. I don't know if you wanted us to take all these out, but I'll just try to pull them out, and I had a bunch in that one. Objects move back and forth. Circular motion. Moving along curved path. Okay, now the next two. Linear. Types of motion continued. There's all the linear. There's a bunch of those too. Okay. Natural motion. Projectile motion. Gravity acts at all times. And again, these two pages were the types of motion. And on page 125 and 127. And here's my required foldable. One of them, difference between mass and weight. And I really am terrible at drawing people, so I just drew stick figures on the earth on both of them. And I color coordinated, and I forgot to use black on that one, but it looked better in blue. Okay. Mass is the quantitative measure of inertia, and just got all my facts, the unit, the measure. Mass doesn't change, weight does on Earth's surface. And then here's weight. Weight is the quantitative measure of force. Then there's Newton, and then the moon surface. So I did like an Earth surface versus moon surface, and their weight and mass on both as an example. And I got the idea off of, I just Google searched it and found an image that I liked, and then I just made my own. Okay, here's Newton's 3 laws of motion, page 131. So we'll do facts by Isaac Newton first. No, I don't think I had, oh no, okay. It's been a minute since I've done that one, so I couldn't remember. Okay, second law. third law. There's the picture again. I went a little crazy with the orange on that one. Okay, and that was Newton's laws of motion. All right, now we're doing energy and seeing melts. Page 133, energy. There's that. That. Seeing melts. My lightning's really bad. It looks like tree branches, but I promise I try to do lightning. I'm not as artistic as I used to be, apparently. Okay, now work. Motion, and then you can't really see that, but I did draw that too. Move it up. Kinetic versus potential. There's kinetic. And here's potential energy. Roller coaster topic, page 139. Conservation of mechanical energy. I wasn't sure what the title needed to be, so I just stuck with roller coaster. I messed up a little bit on this one, but and then I have all those. Okay, now we're moving on. Oh, I don't remember showing you the page number. Okay, here's momentum. I had a lot of blank space, so I wanted to fix that and just throw momentum again. I used a Sharpie, so it kind of bled through a little bit on some of this. Here's impulse. And again, a Sharpie bled through, but it looked good on paper. Centripetal acceleration and force. I did a little different because my scrap pieces of paper were a little bit different. There's my circle with the radius and it pushing towards the center and back. At an instance, acceleration is the result of velocity changing its direction. Centripetal force. That's a V for velocity. Radius, force, pushing toward the center. Center sinking force that changes direction of path. Close it and open it again. Newton's law of gravitation. 147. I really enjoyed my Sharpies, but hopefully you can see all this. I left off the gravitation had added in there when I went back to look over it. AC/DC. And then I have my blue for AC/DC, the middle mixed together in DC. Direct current, have the arrows pointing one direction. And then we have the blue and pink, and I did it a little different. I know I probably should have tried to find a purple pen, but I didn't have a purple pen, so I used both the pens to, and just rewrote over it with the other color, because at least it looks like the center. And then there's alternating currents, where some arrows point one direction and the others point the other. Okay, that was AC/DC on page 149. Okay, here's the open and closed circuits. And I changed the color down here because I ran out of pink. Well, that pink color. And so I have my open and closed circuits. Here's my open with the light bulb turned off, and here's my closed with the light bulb on. Open circuit. And closed circuit. Okay, here's Ohm's law and power. So we'll do on page 153. So we'll do Ohm's law first. Okay. V equals I and R times R. This is one that I got really messy on, but that's amperes, amp. And I'll hold them up together to show current times resistance. Okay, here's power. Electrical power, P equals I times V. So there's power equals current times voltage. So there's power, current, voltage, and then wrote down using Ohm's law and algebra. And then the formulas. Close that back. And again, that was on page 153 for both. And page 155 is elements of circuits. So I have my batteries, wires, resistor, lamp or light, junction, and switch. So I'm going to show you this side first. So there's the pictures, there's battery, wires, resistor. Okay, and now I'm going to show you the others. There's my lamp or light, junction, and whoops, switch. And then elements of circuits. Various components found in circuitries presented are items as seen in schematic drawing. Again, that was page 155. Okay, series and parallel circuits. I did mine a little different just because if I didn't have the visual right in front of me, I would have done them reverse. So page 157, and we're going to do the series as first. So there's series circuit. Elements are one after another. All electron elements at one time. Parallel circuits. And then elements may or may not have currents flowing through them. Okay, 157. Alright, here's the final ones. Magnets and magnetic poles. So here's the magnet. Oops. sticks to a magnet. Does stick. Other magnets, iron. Always paper clips, nail, cobalt material. Things that don't stick, glass, paper, wood, plastic. There's a lot of things that wouldn't stick. What are magnetic poles? And I drew north and south. It almost looks like Tennessee, not on purpose. I just can't draw. What happens when you bring poles together? And that's supposed to be the fields. And then there's the force, pushing against each other, pushing away from each other. And then opposite poles, they push together or pull together. They attract. All right, and so here's my extra credit foldable. Magnet and magnet compass. So the kids can move this back and forth as the magnet gets closer because it's supposed to go away from the magnet. It's supposed to do this. And then I have a definition, lines with Earth's magnetic field. And I'll also have another video for this, but closer the magnet gets to the compass, needle will deflect. And that is on page 160. Oh, and the magnet and magnetic poles is on page 159. Well, that is my notebook. So, thanks.